All right. Well, thanks everybody for joining. We're going to be going through today's session. We're going to be going through our DXF programming and ShopMill and ProgramGuide. So let's begin here. Okay. So as in the past, I'll be your presenter today, Chris Pollock. I'm the East Coast Dealer Support Specialist for Siemens. This is my contact information, so if anybody has any questions in the future, by all means, I have a resource here for you guys to reach out to. Probably best scenario would be email, but if you need to, you can always try me on the phone as well. Okay. So just to give you an update of what we have planned coming up here in the relatively near future, the next webinar we're going to try to do, I'm going to try to do something a little different. So what I'd like to do is kind of open this up, make it what I'm calling an open forum, and really kind of give it over to you guys. And what I'll do is when I send out the email blast for our next session, I'm going to be requesting specific topics or questions that you guys in the field have that maybe I haven't covered at all, or you'd like to go in more depth. During the time of the webinar, certainly we'll be allowing really questions to come in at any point as well. So if you don't get the opportunity to email me prior, it'll still be a forum where anybody can come in and ask any questions or topics they want. But I will ask, if it's something detailed, if you can respond back once I send out the invite and just give me a quick little breakdown of what you'd like to talk about. We're going to kind of build up a session based on your questions. So that'll be in March on the 18th, and then the one after that in April 29th is going to be specific to Sinutrain. So we use Sinutrain all the time as a means of demonstrating or emulating a machine tool control as opposed to being physically plugged into a machine tool. But really, we've just been trying to show you what you would do if you were on the machine. What I'd like to do is actually do a webinar here and showing you how do you really use Sinutrain to its fullest. So how do you set it up? There's all kinds of different ways and tricks to install it to different systems and different operating systems, to what are its full capabilities, supporting all kinds of different configurations of machines and whatnot. So I think there'll be some real good information here, especially when either yourself or maybe customers are looking to get into Sinutrain. This can certainly be a good way to kind of navigate them into it and maybe answer a lot of questions that might arise. So that's going to be coming up in April. And as always, here's our two main websites where you can always reach out to information specific to any of our Siemens-based CNC controls. These are both US-hosted sites. We do have comparable sites hosted all over the world. But in this case, if you go to the first website, it'll go to our main landing page. And then as well, if you use the one below or you pick the webinar link on that first website, both will take you to obviously where all our webinars are stored. So certainly please feel free to utilize all of this information. Okay, so as typical, we are currently supporting the 828 and the 840 products with this tool. However, it's not really specific to those controls. So if you are running a different control like an 808, potentially you can actually still use the DXF converter to support that product. But today we're going to be demoing it specifically to the 828, 840. So as we use the tool and we bring it over to a real life example, it will be in a machine typical of these two control platforms. So as an overview, I'm sure as you guys have seen, we're going to take a look at really driving part programs from DXF files. So we're going to talk about the specifics of the piece of software, which we call HMI CAD Reader. Once we've done that, we'll certainly go in and start showing you the different features and functions. How do I set zeros? What are some different things I can do? The end result here is you're going to get the opportunity to see both a conversational ShopMill program directly from a DXF, and we're even going to go in and do a G-code one, time allotting. So you're going to get to see both common ways. Now, this is going to be milling-centric. However, this works just as easily in a lathe, so either-or scenario. Okay, so we got the HMI CAD Reader. So let's talk about what that is. So your HMI CAD Reader is going to be a piece of software that gets installed to a PC, and it allows you the ability of opening up and viewing DXF files. So as you see here with a quick little snapshot of my desktop, you can you'll launch it on a PC. It'll run specifically on a PC once you have it and you're using it. And then it'll allow you to then create data and bring it out to the machine, or what we're going to do is use it directly in Sinutrain. Now, probably the first question would be, if you don't already have the software, how do I get it? How do we obtain the CAD Reader? And the CAD Reader can be installed from two separate sources. So the first is it does install with Sinutrain. So whether you're installing the trial version or a full license version, the HMI CAD Reader gets installed as long as you've selected that option. And the default is to have it selected. So as long as you, when you install Sinutrain, you don't deselect it, then it will automatically install. If you did happen to deselect it and you rerun your Sinutrain setup.exe, it will give you the option to then reinstall it. So as you see here, now in my case, I already had it installed, so that little blue check mark to the left of where it says HMI CAD Reader would not be there if it hadn't been installed. And then you can literally just check that one box, click Next, drive through, and she will install for you. Now, not only through Sinutrain, it can also be purchased as a standalone piece of software if you wanted to go that route. Here I'm giving you just the part number and probably the best source to be able to purchase it through. Now, generally with this kind of stuff, we do recommend you go back to the OEM initially to see if they are promoting it, because at some point you might want to use them or from a support side. But if you can't purchase this kind of stuff directly from the OEM, by all means, you can call our hotline. That's the 1-800-879-8079. You see here in front of you. And this would be the part number. So the 6, Fred Charlie, that number right there down to the AG8, that is the specific part number for this HMI CAD Reader software. And below that, there is a link here. If anybody requests the link, let me know later and I can send it to you directly. But this is a way to download documentation that will directly support this CAD Reader. So we have a nice little Adobe manual that you can download as well, free of charge, to support the CAD Reader. So this would be the link. So if anybody wants to get the link after the fact, just shoot me a quick email and I can just send you the link directly. Or if you really wanted to type this out, by all means, you can do that as well. Okay, so what is the CAD Reader? How do I start to use it? So typically you'll see the icon that we're showing you in the upper left-hand corner where it says HMI CAD Reader should be on your desktop. If not, it should absolutely be found under your Start menu and Programs. And you'll see that CAD Reader, and by double-clicking on it, it's going to launch this CAD Reader. Now, initially, when it first comes in, certainly you won't be looking at a drawing as you're seeing right here. It would just show you basically a blank area, and then you go and you open up the drawing. Now, when starting to use the CAD Reader, it's a good thing to start to explore some of the functions, the pull-down menus, and just kind of explain. And then as we apply it, you'll get to start to see some of this stuff in action. So first, certainly across the top toolbar, we have our files where I'm going to be going to certainly open as well as save, typical file operations that we're all used to. Under editing not only allows me to maybe undo the last function I did, our start contours, end contours, you're going to see those here in a minute, or selecting drill patterns. Those can all be triggered from the pull-down editing. Also, when you come in here, this is an area where we can maybe select different layers of a drawing if the drawing had been created with multiple layers. You can rotate features, you can establish zeros, all down from editing. View certainly is going to allow us to manipulate the view of the window, zooming, redrawing, but it also does allow us with this geometry info to be able to pick features and elements and find out some data about it. So maybe if I don't even want to create a program, but I wanted to just use this tool to be able to look at a drawing and find out, hey, what's the size of a hole, what's the length of a line. All that certainly can be done here as well. Then you have settings. We're going to go into settings. The first thing we go into, because this is where I come in and actually set up the CAD reader initially. And there is some initial setup you do have to do, so we're going to cover that in some pretty good detail, and that's going to be done directly down from the settings option. And then under your help, certainly we have either content help or an overview to give you the software version. Now, on top of that, you do have your shortcut keys, and you're going to see those. They'll be listed just directly below. This toolbar could be turned on or off, so you do want to make sure it is selected. And then this is just going to give us shortcuts to the functions you're seeing from the pull-down menus. So, you know, our open or save, all the ones you're typically used to. We got the little bullseye there. That's your set 0. Then you have the red dot with the arrow to the right or coming to the bullseye. That's starting and ending contours. Now, some of these things, as we start to play around with different features, the buttons may change because it is relative to how we've set up the HMI CAD Reader. But in general, most of the stuff you're going to do, you're probably just going to use the standard shortcuts to access those functions or those features. Now, I mentioned the first thing we're going to do before anything else is the initial setup of the CAD Reader. And what happens is when you first launch the CAD Reader, especially when you first installed it, a couple of these things are just going to come in as basic defaults. Now, we see where it says access names is the first one I'm kind of pulling out here. Now, this generally you don't need to adjust, but we never quite know how your machine's configured. So if in fact, you know, I need my primary tool axis isn't really Z, which would be the third axis, maybe it's X or Y for the way your machine was commissioned, you have the ability of changing those around. The two that are extremely important would be your catch radius and the options pull down. So the catch radius we're going to explore here, and really that has to do with if there's any issues with the actual drawing. So if you have lines that aren't intersecting and you need the system to automatically merge them together, well, there's a tolerance value, and the tolerance value is part of the catch radius. Now, although we're showing you this to be a metric number, there really is no metric or inch here. A drawing's a drawing, and a number's a number. So whether the drawing shows a line that's 1 inch long, it's not really an inch. It could be 1 millimeter. It's just a distance. So kind of get away from the thinking that, oh, it's metric or inch. This is a distance. So if I'm in an inch drawing, 0.1 would represent physically 100th thou. So what happens here is if you have a very large value, you might find that this is starting to kind of merge lines and features together, and it's all because it was left at a default value that would be appropriate had this been a metric scale drawing. But if it's really an inch scale drawing, now it's just this huge value. So you are going to want to go in and reduce that. I would say a common number here might be a couple thou. That would be a standard value that you would use. Now, the options pull down, that's really important, and this is where you're going to first define what kind of program will I be creating from here. So we have ShopMill or shop turn, manual turn, and then default. So the two we're going to be talking about today is ShopMill and default. ShopMill physically supports a ShopMill conversational program, and default would be a basic G-code file, and that would be certainly universal. From there, you want to make sure your plane is established correctly to match your machine tool. Your output window, where it has diameter on or diameter off, that would be if I was using a lathe, and a lathe that was supporting diametric positioning for the x-axis, I would have diameter on. If you're milling, you would want diameter off, and this way the system's not compensating for diametric values. The symbols, large or small, can change the your shortcut key size. And then the final would be your output resolution. And this would be, you know, your standard number of decimal places. So this would be the only area where you really could differentiate the difference between a metric or an inch program. You know, your standard from the industry standpoint would be 3 decimal places for metric, 4 for inch. So you do want to come in here and make sure you are at 4 decimal places. So this way any of your output will be to the, you know, normal scale that you would expect it to be. From there, you say OK, and then we are good to go. Now, the next thing we start to see here is under settings, we have a contour tracking option, and that changes how features pick. So we'll show you that a little bit when we start to pick some elements. It'll dramatically change how things start to click, especially when you have multiple lines with multiple intersections. That's when things get a little muddy or a little tricky, shall I say. You can also use what's called the auto zoom feature. That's real handy if you have a lot of detail and you don't want to have to keep on re-zooming different sections. As you pick lines or features, it'll auto zoom to that. So we'll demo that for you, and it's kind of a handy little function. And then you can adjust all the colors, and all the colors based on layers and targets and all that. So I generally leave that to the defaults, but sometimes it is nice to be able to go in and modify some of this stuff, tailored a little bit to your needs. Okay, so let's from here go and start to demonstrate the software. So let me just share our specific. Now I'm going to share. It's a little different than I've probably done in the past. I want to share my entire desktop. So just give me 1 second. I'm going to stop the sharing for a brief moment because I want you to see how it's going to look on the desktop, how it launches, that kind of stuff. So we are going to be sharing our primary desktop. Okay, so let's just minimize our PowerPoint. We can come out of this for a second. Alrighty, and let me just get a couple of these things back up. Sorry about this. So I just want to bring up the Windows. Okay, so now you're seeing my primary desktop. So once the software is installed, again, I'm expecting to find this CAD with this, the little compass and the C and the D shortcut here, and it's going to be listed as your HMI CAD Reader. Or you may have to go over to your All Programs and find it through here. So generally, you're going to find that it's going to be installed typically under the Sinutrain option. It's hiding on me now. But anyway, we would find it either within the pull down or if I have the shortcut here. So we're going to launch it with our shortcut. It's going to launch the CAD Reader, and this is how we would generally see it first come in. Now, I've already done some setup on mine, but we are going to go through the steps of how I would set up the software. So the first thing you want to do is you want to go to the settings window. We want to come down, and I would suggest probably going to options first. That would be the standard. And in here, this is where I can select whether I'm doing ShopMill, shop turn, maybe our default. Certainly pick the plane, whether I need diameter on or off. Again, this would only be selected if I'm turning. And then my number of decimal places. And certainly this is important whether I'm doing metric or inch as far as how many places do I want to see. So here, if I was going to metric, I would typically put this to 3. So in our case, first we're going to create a ShopMill program and hold out 4 decimal places. Now, the next thing I had mentioned was the catch radius. So here we have some kind of a value. All right. So we currently have a 0.1 millimeter value here, right? So that's going to control the distance or gap. So let's go take a look at a program that or a drawing that I've created with some specific gaps so you can start to see how this is all going to work. So let's just bring in our file. So I've created a simple little drawing with some defined gaps. So this one happens to be a 100 thou gap. This one is a 50 thou gap. Obviously, we have values that are even larger here. So when I go to select features, and we're going to go through this as we create a full one, I'll step you through this in a lot more detail. Give it some name. So as I pick entities, all right, see how it auto-changed, so everything turned green out for me? Well, the only reason this happened was because the tolerance there was equal to or greater than this gap. So if, in fact, I didn't want that, I'm getting unnecessary picks, which can happen, then you want to make sure you reduce this catch radius. So if I had it to, let's say, 50 thou, now as I start to pick different features, you'll start to see here, it doesn't let me pick these lines. So again, if the other side of the coin, if you have that value too big or too small, and you do have issues, and you'll find that, hey, why can't it connect? But the scary part is if you put a value way too large. So let's say, for argument's sake, I had a big value in there, maybe an inch, And now we start to pick features. Now you're going to start to see it's going to give us portions of an element that I might not want. So this thing came all the way over to my center hashing, which was a big gap because that gap was greater than it. So just be careful because this can certainly give you some pain points. Okay, now just talking about the layout and whatnot, when you're looking at the CAD reader, there is a little display in the lower left corner. This is very handy. It allows you to kind of track not only where the mouse is, but you can figure out where the zero of a print had been created. So in this case, I have a little bullseye, and if I look at my display and I hover my cursor right here in the center of the screen, I can see that that's 0, 0. As well as you have the hash marking to kind of give you some perspective on scale. Okay, so now the next step will be to start to talk about really the specifics of bringing in a legit drawing and starting to pick some features and starting to see what happens here. So we're going to come back into our PowerPoint real quick. And nope, let me just go back one slide. I had advanced through. Yes, thank you. Okay, so we'll go in and we're going to select our files. Now, what's important to note here is the file types or files of type. This software will only support DXF files. So when we do the pull down here, you notice it's only giving DSX or all files. DXF is, by its general nature, only two-dimensional, meaning it can only support physically 2 axes. So you can't do any 3-dimensional geometries with this software, just the nature of DXF. So this is only going to be there for 2D types of profiles. From there, once you pick it, certainly make sure that our option, as we just showed, is set properly. And then from there, we come in and start creating it. So the first thing we're going to see, we're going to find a drawing, maybe zoom in, and we're probably going to want to establish some zero. So on our first example, we are going to figure out where the zero had been created on a part. Quite commonly, when guys draw, they don't think about zeros. Us in the machining world, zero is extremely important, but typically if I'm drawing on a screen, a zero is not as big an issue. So with that being said, you'll find that zeros are all over crazy positions. So here I'm going to show you how to move that zero around in space. Then from there, we're going to start to actually create elements. So what you just got a quick little snapshot of, we're going to go through and I'm going to explain the exact steps and why I'm picking what I'm picking and what I'm expecting to see happen as I pick these features. Once we pick those features, now we're going to go create a second contour or second boundary, and we're going to jump to the next one. And now we're going to get to see kind of what happens when I have lines that intersect other lines, which is pretty common when dealing with drawings. And we can play around with a couple different methods on picking features, which we'll talk about. Once we've done that, then it's time to physically create the program. So what happens here, what this software does, is it will create what's called an MPF file. MPF stands for main program file. That's the exact same program file that your machine tool runs as a part program. So with this, once you physically come in and save the program, we're going to go and open it. And when we open it, we're going to see that it's putting this information into a format that I can now add functionality to and create a part program from. So we're going to follow the whole process right through. We'll use Sinutrain as we usually do to actually create the part program. So let's get started. All right. So bring up our CAD reader and let's bring up our drawing. So just as I showed you briefly, I'm going to go to Open, find, and browse to wherever you have your example, and we're going to open it up. So now here would be pretty common. This would be a pretty normal example of what I would expect to see when I bring in a part drawing. Some dimension lines, a bunch of features, maybe a lot of different views that could be on the drawing. So the first thing I want to do is I want to clean things up a little bit, just to make it simpler for you as far as what you're viewing. So what we want to do is we want to use this one little icon right here that's got kind of like a scale and a circle. And what it's telling me in the bubble is this removes any dimension lines or any hash marking that's in the part program. So the software looks and it determines what it feels is a dimension line or a hash line, and by toggling this, it suppresses them. Now, you're going to see as we go through, we're going to modify and change around the drawing a little bit. not at any point of this does it actually edit the DXF file. So you don't have to be afraid that, we have a feature here, this one right here, that allows me to delete geometry. So if I pick this, I can start clicking on features. So our initial instinct would be, I just deleted features that I need, and now I've just ruined the DXF file. Well, at no point does this actually delete these features. So if I was to reopen the drawing file, because you're never saving the drawing file, it'll go back to the exact state it was in when I got started. Okay. So this is just suppressing or hiding what we're viewing. So here, first thing obviously I normally do is get rid of all my dimension lines. Now, this kind of confused me when I was first getting used to this software. And what it is these little hashed or dotted line boxes that we see right here. So what I have is it says select the machining range. And my first gut would have been, oh, this must be a zoom. It's not actually a zoom. See, here I have the zoom with a little window. I can zoom, I can fit. But you notice how as I zoom in different features and I click the fit button, it's always going back to this full area. So if I had 3 or 4 views, it would be zooming way back out, and I would be seeing this whole entire print all the time. So this is a way for me to basically tell the system, hey, I don't really care about what's outside of whatever this box is. So now it's defining, it's saying here in the pull down, select the machining range, right? It's really defining where I'm working within. So now, with that selected, if I zoom in and I hit fit, it's going to go back to this window. So it just cleans things up. I don't have to deal with whatever's outside. I can kind of concentrate on the specific elements that I'm working on. Now, if I do need to get back out for later, I can click the delete machining range, and it will go back out. I can turn the dimension lines on. So even though I'm kind of modifying things a little bit to make it a little easier to pick stuff, you can still get back to those values. Now, we have the little information on, this is my geometry info. So if I want to start to find out different things about entities, I can start to look at them. So, first, if I start to look at these numbers, they start to look a little funny to me. The length makes sense, but my absolute positions seem a little strange. Same scenario if I was to look at, holes, and I'm kind of paying attention to where maybe the center line or center point of the hole is, it doesn't quite look right. So this would be where I would use the scale down the lower left-hand corner and my cursor position to try to figure out where the part 0 is. So in this case, in this example right here, my part 0 is to the left of the part in X, roughly where my cursor is, but I'm actually even way off of it. I'm 2 inches above 0, so my 0 in the Y is down off the bottom of the part. Again, from a CAD side, it doesn't really matter. But now, this is important, because if I was just arbitrarily picking geometry, it would output this to the machine, and then I'd have to reproduce that part 0 when I go to machine the part. So what we're going to do first is we're going to look at how do I establish a new part 0. So I can use my bullseye, or I can go to the editing function, come down, and look at the set 0. Both will give me the same options. So what I have here is I have some different scenarios as to how I can pick features. So we do have an element center. And when they talk about element, they talk about any feature on a physical part. I can pick the start or the end point of an element. So if it's a straight line, which side of the line do I want? You can do a free input. So that would give you an actual scale to be able to type values into. Or I can give it the position of the mouse. So if I give it the position of the mouse, I could roughly eyeball some arbitrary location and establish that to be a 0. Generally, that's probably not the most ideal way because I'm not truly controlling the 0. So normally, I would either pick like an element center. So here I could say, hey, I'm going to pick this line, or I'm going to pick a circle or a feature, and it'll find the middle of it. Now, what's important to note is take a look at when you're picking the circle. It's not finding the center of the circle. It's finding a midpoint of where the circle was created, the way it was drawn. So if you do need to get to the middle of a circle, then you will have to pre-establish some way of getting it in there. Whether you had a couple hash marks that would create a cross at the center of the circle previous, or if I knew where that was in relation to another feature, like here, if I establish my 0, 0 now center of the part, And maybe I knew, and I could kind of tell that by measuring a little bit. If I pick this center of that circle, I could see, okay, well, the center point I know now is 1.125 away from this feature that I just found. So if I need to get it there, and I don't have the luxury of going and maybe modifying the program or the drawing through some of the drawing utility, I could then go back to my bullseye, go to my free input, and tell it, okay, let's move the 0 based on an actual position that I know. So you can manipulate things that way as well. So you can get kind of creative. If you have a known specific spot, you have to force this 0 to be. For our example, we're going to use the element center, excuse me. I'm clicking too many things here. We'll use the element center, and I'm going to pick the center of my feature. So I've cleaned up the drawing. I've established a 0. Now I'm ready to kind of tell the system what am I doing. So under settings, I do need to pay attention to what I have picked here, contour or drilled holes, because the display will change too. So if I know I'm going to pick some holes here, I do want to make sure I've pre-selected the drill hole feature. If I want to do a physical contour or shape, it'll give me the appropriate contour buttons, but I do need to have the settings set up for that. So that's something you kind of bounce back and forth from quite a bit, especially if you know you're picking holes at some point. So from there, you have your 2 buttons, the start and the end point. So you're always going to obviously want to start with the start point. And just like in moving the 0 around, we have a couple different ways to pick entities. So I can pick the center of an element. And again, an elemental line or arc, any feature. I can pick the start or an end point, and it'll be specific to my position of my mouse, or I can just click with the mouse and it'll try to start there. So in this case, I'm going to pick the start endpoint feature. Now, I do want to give this an appropriate name, and the name is going to be used when I actually get to creating things in the in my part program. So maybe I wanted to call this, I'll call it Contour 1. It's going to be my first contour or shape or boss or whatever you're familiar with. Now, once you've defined the name, you click OK. Now this will stay depressed, and it's waiting for you to start picking an entity. So where do I want to start? Do I want to start here, here? You see how they're going yellow? Now, I haven't clicked anything yet. I'm just trying to figure out where I want to start. So let's say I want to start top left corner. Now I'm going to click the element first, and it's going to give me my bullseye. So if I was on the wrong side of the bullseye, I might want to restart. And then you want to pay attention to the arrow direction of that little red bullseye. See how it moves around? So that's going to define the direction. Generally, I want to pick things in the direction that I'm going to cut them in. So if I'm going to be walking around the outside of this part and I want to climb mill, I'm going to walk around this thing clockwise. Okay, so I click the same feature a second time, and now I start to look. So see what it's doing is it's kind of guessing and trying to pick different locations. I get all these crazy picks. Well, that's because I have not gone back and adjusted an appropriate catch radius. I'm still seeing it 1 inch. So that's where this becomes very important. So I'm going to set mine to maybe 5 thou. All right. Now we go back. It will retain the name of the last one until I'm done with the contour. All right. So let's go repick. Now you see how since everything intersected, there wasn't any scenarios where it was questioning which direction you want to go because something was maybe what it thought was intersecting. It will automatically chain the whole feature. Now, you're not tied into picking the whole feature, however. What you do is the next step would be you pick the endpoint, and you have the same kind of options as you had in the beginning. So I can pick an element endpoint, but now I can pick which line I want to stop at. So if I only want a half of it, I can go in and pick half of it. If I want the whole thing, go back to the last arc, click it, and now the whole entire feature will chain. So once I have it all green, that means that that contour has been selected. Certainly I could save it right now and start building the program, but I want to create a second contour because I know I want to catch this feature. So now we're going to go and we're going to, well, it's like update day. We're going to go and we're going to select the start of contour again. I'm going to give it a new name. I'm going to call this contour 2. And now we're going to go and we're going to pick this inside feature. So now you see how I have an intersection cross, and it's kind of making a guess. So what I need to do is I need to move the cursor to the point that I want. Now this strategy, or what's happening right now, is directly in relation to this contour tracking feature. So I have intersection or element. So as I start to pick, right, do the same thing as we just did. Now you see how it guessed a lot more accurately here. So I'm going to pick that, pick that. So you may find that the element strategy makes more sense for the feature you're picking as opposed to the other. That's solely up to you. Now the other thing that gets handy, especially when you have a lot of detail, a lot of segments in a drawing, once you've picked the intersection strategy or the contour tracking strategy, is the auto zoom. So if you have auto zoom on, so just by clicking it, it'll give you a little checkbox right there. Now, as I start to create the shape, it zooms me right to the question, right to the area in question, right? Boom, puts me right there. So on this part, it's pretty straightforward because it's not that big a part. But if I had something with a lot of detail, now it's going to drive me right to that portion where I potentially have a choice in the intersection, and I can click on the appropriate feature. Okay, so we've chained it. We've got all the lines. Now I want to pick the physical endpoint. So I go and select endpoint. And again, if I want the whole thing, I'm going to pick the line, that last line, and closer to the end of it. If I wanted just portions of it, I could pick this portion, this feature. So I'm going to click the whole thing. We see the whole thing goes green. And now I have some features or some functions. So the next step here is to now take this context, save it, and create a part program. So at this point, I'm going to go File. I'm going to select Save. And it's going to ask for some kind of a name. So it is going to go to use the default name of the drawing file, which I'm OK with. So we'll call it milling example. Now I am, just for my own reference, going to label this ShopMill or SM, so I know in the future. And I click Save. And now what it just did was it actually went and created a ShopMill program. So if I go into Sinutrain, as you guys are used to, and I'm not going to spend a lot of detail talking about Sinutrain because you've seen programming before, hopefully, or you can look at other webinars. But here, if I was to go and look at the area where I just saved that file, so I called it my ShopMill milling example DXF.MPF file. Here's the file right here. If I open it, this is what I'm going to see when I've created a ShopMill program from contours. I'm going to see an initial header page. It creates automatically for you, and however many contours I had selected. So in this case, I got contour 1, contour 2. So now it's up to me to then go in and modify this stuff appropriately. So, you know, I happen to know I'm an inch. Maybe I want to use a specific work coordinate. What do I want to do for my block? You know, you guys should be familiar with all this type of stuff. So I'm really just setting up what's appropriate for this job. But I'm now writing a program. All right. All right, so I fill out this page. Now, if you're used to these always coming up with the default values of what I last set, there is no default values per se out of DXF converter. So it's always going to put it to just a generic setup, and then you'll have to come in and just do this quick mod. I hit accept. I save it. Now, it doesn't know what we want to do with these contours, so it's up to me to kind of decide. You know, if I know that contour 1 and contour 2 are just simply a basic profile, well, then I know that I'm going to need to shove a profile or a path mill between each of them and break up what's happening. So it's going to be up to you to methodize it the way you want. But what's nice about this is I can open these and I can physically get in and see all the features, see exactly what the converter picked for me, and it's all editable. So you have no idea here, viewing it at the machine tool, that this was created from a DXF. For all you would really think, you just plugged in the values. I mean, this is exactly the same way, right, that you would have normally created this stuff had you been on the machine. So from here, you know, pick the appropriate strategy, go in, simulate, voila, we got a part program running. Now, this is an interesting scenario, so be careful if you see this. What happens is, and this is a metric inch little trick, sometimes when you first select the feature, it actually is burying a G71, and the system will automatically take it out. But if it comes in too small, which now it's making a little liar out of me, it's going to, oh, it's on the first one, sorry. So I want to come in and just accept it. And now it should be correct. So this is an inch metric scenario. So there you go. It resized it. If I was to have opened that feature up in like an external editor, I would see where the system would have automatically buried in a G71 command. And what happens is the machine tool will actually automatically strip that out, realizing, hey, he's not really a metric, he's an inch. But that first time, if I hadn't opened it up and just resaved the shape, it could retain that. So that's why the first time it kind of ran it really small. Okay. Now in this case, I'm chopping everything off because I use the exact same strategy for both. You know, the reality is I probably would have wanted maybe it be more like a shelf. So here I'll have my first one be an inch down, and then we'll have the second one be something a little smaller, and now you can see where we're leaving that. And everything you've seen in my previous webinars could now be used, because again, this is just a contour. Okay, so next step that we're going to go into or take a look at, let me just bring this up, is the holes and how do I support the holes. And there's a couple of tricks I'm going to show you here. So not only how do I pick holes, and that's pretty easy, you guys can probably figure that out on your own. But what's neat is as you start to pick and add features, the system allows you the ability of doing an attach to function. And the attach to actually allows me to put information into an existing program without having to build it all up again. So whether the program had been created by the DXF converter or it was just some arbitrary program that you created where you wanted to add some features to, you can do this attach to function. So it's really quite handy being able to insert stuff that came from a DXF file into any part program that you have. Now certainly you want to make sure that the file you're attaching to matches the way you have the settings function set up in the control. But what will happen is you're going to get to see where it's going to shove in the positions that we're about to pick. We're going to do a bolt hole and then random, and it'll allow me to decide what I want to do with those positions. And then I have to just do my normal editing features. So as like before, we're going to jump over to our CAD reader. So here I would have either reopened the file or had it been already open. And now we decide what is our next operation. So in this case, we're going to create some holes. Oops. Sorry, guys. This is IT stuff. Okay. So in this case, we're going to create some holes. So I do need to go to Settings and select Drilled Holes. That's important. And that's going to change my hole strategy here. Now, the way the holes work, and again, I can see this here. I can get it through a pull down, right? You know, we can do drill pattern here and pick these holes, or by clicking on the first one to the left, that's the start hole, and then this is going to say, okay, I'm going to end my holes. So I click on the start hole feature, and now we have really 4 options. I can do any random location, so I can just start clicking circles, and it'll find the centers of each of those circles. I can be creating holes with some kind of features, like a row of holes. I can do a bolt hole circle, or I can do a grid of holes. So in our case here, I'm going to do a bolt hole circle first, so we'll select hole circle. Now you see how that first one went purple for me? It's just guessing. You know, it looked at the drawing and said, hey, there's a circle here. Is this the one you want? So it's up to me to come down, put my cursor over the one I want, and I can pick any of these. So maybe I'm going to work on the smaller holes in case for some reason they had a different center point. And I click the first one, and it's making a guess. So depending on where I picked, you know, you want to make sure you pick the feature. And then what it'll do is it gives me the ability of even changing the direction of the bolt hole. So depending on which one I highlight, you can see how it changes the arrow direction. So what you do is you pick that first one, and then really pick any of the second ones, and that will now bring me in. Now I don't have to pick every single one. it's going to kind of really auto-chain it for you. So all I need to do now is just click End, and it will give me all of them. If I had clicked them back, I don't have to select them all, but generally it's trying to give you all of them. Okay, so that's my first series of holes, and I'm just going to disable my auto zoom. Now the other most common way certainly would be random holes. So let's say for argument's sake I was going to go in and I was going to pick any position. This would be random holes. So now again it's just going to kind of grab whichever one it's thought to grab, but up to you which one you want to start with. So maybe I wanted to start with this one on the left. And now you're going to pick each hole, and the order at which you pick them is going to be the order at which it puts them out. So that same scenario, it's going to be the exact way it drills them. So if I do like a little zigzag pattern here, then it's going to drill that exact sequence that I see, starting with the first one I picked, going to the last one. And then I want to make sure when I'm done picking, I click End, and now it's stored. And you see I can't pick anything else anymore. It's stored these locations. So in this example, this scenario, I need to shove them into a part program that already exists. Right? We've already started putting some information. So what you want to be careful with here is you want to make sure you don't do the save or the save as, or it'll rebuild that file. You want to make sure you pick the attach to. It's going to automatically pick, in this case, the last program I had been working on. If it was something else, I just have to click on that program, and then I click Save. So now, if we were to go back to Sinutrain, it's saying, oh, we detected something wrote to this file. So now if I go back to Sinutrain, we have the contours like I created them already, the header like I did before, but now we get two features. They happen to auto-chain, but I can now cut, copy, paste, and move them wherever I wanted to within this program. So in this case, if I strictly wanted to add a simple little drilling cycle, I could come in. We can establish the drill, right? Give it some depth. Now it's going to drill. Now in this case, it would drill at all these locations twice, right? Because I have two chained. But maybe I wanted to drill the bolt hole pattern, and then I want to go back with a different end mill and maybe come in and do this routine again. So I could really obviously get rid of this because this is redundant. These are redundant holes. I just want to show you some different scenarios. But in this case, maybe I'm going to go in and pick a different tool. I'm just going to pick a big end mill for argument's sake to do like a counter bore. So maybe I'll do 0.5 here just to show you something different. So it's solely up to me to start moving this stuff around wherever I would want it in the part program. So if we go simulate, nope. Doesn't like something I did here. Oh, I have this on shank. Let's use it as a tip. It was trying to calculate based on a tip, and I'm using an end mill. Certainly I can't calculate a projection tip on something that's flat. Okay, so now we're back up to where we were before. And here we're going to see, and you see the order, and there is my zigzag. So that's where it starts to become apparent. So, if you had 100 holes, 1,000 holes, you just start clicking. Okay. So in this scenario, what we've seen so far, we've been doing it in ShopMill, and it would look very, very similar had you done it in ShopTurn. Obviously, it would just be values more relative to turning than milling. But what if I don't have ShopMill, or I'm working in a CAD-CAM-based program and I want to add something to it, or just a cynical G-code? Well, you can do everything you just kind of saw here. We can also do in ProgramGuide or in G-code. So we're going to go through that now. So in this case, first thing you got to do when you want to support ProgramGuide or G-code-based programs is you got to select the default option as opposed to the ShopMill option. So ShopMill, ShopTurn, and Manual Turn all support different pieces of the software, obviously. Default was be supporting standard G-code. And in that case, there really wouldn't be any difference between lathe or mill. So if I'm doing ProgramGuide for turning, I would still select the default option and then pick my diameter on or diameter off, and away we would go from there. And then obviously the orientations, all that is going to stay the same. So I got to come in and select that. Now what you're going to see is by changing the setups, we're going to get a new icon on our little toolbar here, or on our shortcuts toolbar, and that allows me to start to create some labeling. And the functionality may look slightly different. See, I have a start and end label as opposed to start label. That's going to be the difference of drilling or milling. So this is a slightly different mechanism that I might be used to, and certainly a little different than we just saw with the ShopMill. Okay, so what happens here when I'm doing program guide features, I need to give, in milling or contours, I need to give a start and end label. And the labels should be unique. There should be some slight difference. You don't want to have the exact same input for each of the two labels. So like I have an S_shape1 I'm showing you here, and an E_shape1. That's saying, hey, start and end. That's why I'm using the S and the E just as kind of as a terminology, start and end. If I had shape1 twice, it would build it, but then when I go to actually use it, if I want to like do repeat functions or whatnot, it would not know where the beginning and end is, because it does use unique labelers when we do this label functionality. From there, I'm going to select my start point just like you saw before, pick my features just like you saw. So the rest of the path, the rest of my order of operations here is going to be identical to what we just did. Now the output's going to look a little different. Same scenario, if I wanted to do the inside contour, I would come through and I define my labels and I start to pick it out. Now when I get to bolt hole patterns, the start label looks slightly different, or any hole patterns. Once you pick the holes, it's just asking for a straight label. And then you have some abilities of calling things up by labels. A lot of times I just copy and paste the features up to the necessary area that I want to use them in. So here, I can go pick my holes. And then the rest of the picking is going to be the exact same way you just saw. So come in, tell it I'm drilling, pick a strategy, start to click my feature. Once I've clicked everything I want, tell at the end, and I'll get the resulting dotted line showing me the holes I picked and the direction I had picked. And from there, you're going to go in and we're going to create a part program just like we did before. So certainly I'd want to use a unique name. So I'm still going to do the save because I haven't built anything yet. And that's going to give me now features in G-code. So here you see like the S profile 1, N profile 1. This one I happen to call this example. So that's what's going to kind of look like. You're going to get this G-code type of output that you can now use in a G&M part program, and we can start inserting in different areas. Okay. So let's go do that. We'll go run through an example of that. Certainly, just like we were talking about earlier, I can do the add to type of functionality as well. All that works the same. So let's fit this on my screen. Now, like I said before, I do need to change the settings and make sure I come down to my options window. Once I'm in options, I want to pick the default. Everything else for me is really going to stay the same. So I'm just changing the default, and that's going to now trigger it to be supporting some type of G-code functionality. Now, if I want to go pick my catch radius, you notice it's grayed out. So be careful with some of this stuff because there is some dependency on where I'm at. There is no catch radius when I'm turned on drilled holes. That's a contour function. So I need to have selected the contour to be able to access the catch radius field. And since I made a change, it went back to a default value. So here I want to put something a little bit more realistic to my job. All right. Now, we now get this new button, right here. So the new button is how I define the labels. Now, if I don't define the labels, right, so let's say we just go in, let's pick some features. All right, grabbed it. Let's end it just like you saw before. And so I have some features. Now I go File, Save, and we'll do a Save As, and I want to call it actually ProgramGuide. Oops, I'll call ProgramGuide _ so we'll build it there. So now, if I was to look at that new program, there's my. Where are you? Let me just jump back in. I'm not seeing it here. Oh, why don't I see it? Let me do it again. program guide. Okay, let's see if that's, did I know, oh, maybe I missed the features because I did it twice. Let me just do that one more time real quick. All right. And again, what I'm trying to show you is what happens if you don't fill out your labeling. All right, so let's pick the end position. There it is. I'll save as. I wanted to call it my program guide. And save it. Now if I go and open, I should see. All right, good. It looks like it saved it. Let's go jump over. And now we're going to get the, where'd you go? What am I doing? Always fun when you do this stuff live, right? I have too many, there it is. Okay, good. All right, so we just created this program guide. So what did it do? Well, it brought the geometry over, and that's where I actually see that G71. See how it went away? So when I bring it over, since I have no labels, the only way, I'm limited as to what I can do with this feature. So I could use it as a sub, or maybe I could shove it between some operations, but I am limited as to how I would want to be able to call this up in a G-code program. So it's important to get the labeling. So the labeling is going to come on either side of this specific geometry. So for us, if I had created the labels, the unique labels, now I will start to see, so I'm going to call this, I'll call it just shape 1 or S1. I'm going to call it end S1. Say OK. So once the label's triggered, now I'm going to pick things the exact same way I did before. And we'll go grab the endpoint of it. All right. Now we'll do a save as. I'm going to save it as the program guide one. So I'm going to overwrite the one that was there. That's why I got to be careful. See, it's even warning me that's going to replace it. So now if we go and reopen it, now you see you have this end and these two unique labels. Oh, did I go? I must have fat fingered it. I really wanted. Now they are editable, which is nice. So if I did do a typo like I obviously just did, then I would be okay. All right, so the start and end labels, what does that allow me to do? Now this allows me to start calling up and using the feature somewhere. So, if I was to now start literally building a basic G-code program, oops, I'll move this down. So generally what I do is I create my shapes and stuff below my M30 or end of program. Here we can do some atypical program structures, absolute, work coordinates, unit of measure, maybe my orientation plane. Let's go grab a tool, the normal G&M code. So we're going to grab a half-inch tool, do a tool change, maybe tell it my feed strategy, fire up our spindle. All right. Okay. So let's say for argument's sake right now I'm ready to cut and I want to cut this profile, this shape that I just created. Well, at this point now, if I physically go in and use my contour mill, I can start to use these contour cycles with these shapes. So I'm going to first need to basically tell the system, just like I would have had I been doing normal G code, I have to tell it where the shape, what the shape is and how it exists. So normally I would have come in, created a new contour, or then when I'm ready to use it, use the call contour function. Well, you're still going to use the call contour function, but normally you're used to calling it as a contour name. And that's going to be the difference with the way it comes out in the G-code side. Instead, you're going to use the label routine. So now in this case, I just want my label to match whatever my unique labels were. So I think I called this S1, and I think I called this S1 down here. So I make a quick change to my labels and save this event. So what this is saying is, hey, I'm now going to look for an S1 underscore, or S underscore S1 to an E underscore S1. And now I'm going to do that for whichever of my cycles I had picked. So this is the exact same mechanism I would have normally done when G-code programming. The only difference is I got to remember to change this to some of our other methods of calling up shapes. You know, I can also call up shapes from a subprogram. So like the way I did it first without doing the labels, I could just say that as a subprogram. And then I could have called up the name of the program from here, or I could use unique labels inside of a subprogram. So there's a bunch of different ways to call this stuff up. So in our case, I'm going to do a simple path mill, you know, fill out my normal features here, save it. Now, I don't have a blank established, so I'm just going to see the wireframe. So here I'm going to get my wireframe. But just like we would have normally been doing in G&M code programming, I can go to various, establish a blank, and we'll say it's 5.5. Save it. Now we go down and simulate it, and we'll get the blank now and start to see. All right, so there we go. So now we're going around and we're milling the profile just like we did in ShopMill. So the labels is really the trick. You know, you want to start to use those label features. And when you go to do more than one, so like we have, you know, we have a whole separate feature right here. Well, when I go to do the next one, I want to make sure I come in and recreate my labels. So you pick the label first before you go to grab anything, because you don't get the option to select the label. So you want to make sure you come in here, and I'm going to call this start underscore called shape 2 and end underscore shape 2. All right. We're going to say OK. Now we can start to pick our features just like you saw before. All right, make sure I chain around properly. I shut my auto zooming off, so now I just click around and won't keep changing my display. All right, pick the endpoint. All right, so now it has those features, and now we can do the attach to as opposed to save, and now it's going to add that into that feature. So if we go back to the program, and we go back to Program Manager and reopen it, now I'm expecting to see my, thought I typed that properly. Okay. Did I see this G71? That was that little scenario I was saying just to watch on. So the system doesn't necessarily know, and you know, being a European-based control, a lot of times we default things to be G71. So what happens is when it first builds this, it's defaulting this to potentially be metric. Now, if you simply open the file or open the feature and save it, it removes the G71, and now I don't have an issue of it, you know, scaling or showing it the wrong size. So you do want to be careful with that. If it looks like it's coming in really small or really big, obviously the scale's wrong, just open it up, save it, and that default G71 gets stripped out. We're doing that at the control level. Okay, so now I have my shape, and then I can start to call that up. So, you know, maybe for argument's sake, I needed to, you know, do it over here. I can do the exact same feature, go to the cycle call, pick it up, and keep adding in the features. Now, the last thing I do want to show you, and then we can open up for some questions here, is handling drilling, because the drilling is slightly different when in the G-code side of the control. So back at the CAD Creator, we go back and change my settings to drills. So now, when I have a label, I don't need to do a start and end label. I just need to come in and tell the system, you know, just a general label. So drill. Let's just do I don't know, drill 1. So I type in the name, hit enter, select OK. I'm on the drilling routine, right? Because I selected that before. So now it's going to work the same way I saw before. Pick the feature, click on it, the direction, define my direction. So we're going to go this way, and then pick my end as long as I want everything highlighted. Picks all of my features. Once I have them in, I can certainly go back and pick the random holes. I just want to port it over so you can see kind of what it's going to look like. So we go over to our file. I'm going to attach it to that same program. Now, the one thing you always got to be careful with, especially the way I'm doing this here, bouncing in and out of Sinutrain and using a common directory, is when I leave it in, it's going to either want to reload, or worst case scenario, I want to make sure I come out and reopen the file, because technically ShopMill was opening that file as well. So if it doesn't come back in, sometimes you want to make sure that you close it before you reopen it. And yeah, see, I had it opened already, and it was trying to write into that one that was open. So sometimes that's, it's a better habit to get into at least shutting down the file that you're currently editing before you start writing to it. So unfortunately, I just have to do this again because I had the file open. And let's just pick holes. So that's just a pretty normal PC type of scenario when you have multiple programs writing to the same file. Okay, so we'll attach it to our program again. Come on over. And we get, there it is. So there's our drill one. So probably the simplest way to utilize this, there are methods to call it and whatever. A lot of times I'll just copy and paste it, move it up, especially drilled holes. It's pretty quick and easy. So here I can mark, cut. Let's just move it on up. So I'm going to put it just after my M30. So let's paste it here. And now it would be my typical G&M code type stuff. I want to go grab a tool, obviously. So let's go grab a drill. Let's go give it an M6, do a tool change. Let's fire up our spindle, some RPM, maybe a different feed rate if I wanted to. The normal program stuff that I would typically do when I'm about to drill. And then I'm going to go to my drilling, take a can cycle. So we're going to drill some holes. Half-inch deep should be fine. Now, modal call, right? Just like I would normally do with any drilling. So I do want to then down here make sure I type in my M call again to shut my drilling off. All the normal G&M code rules apply. So from there, we go to simulate, and now we should see it drilling some holes. So it rolls around the feature. Oops, sorry, guys. Move that over there. And drills our holes. So let's go and zoom in. Now we see we got some holes. And then you can go back and obviously pick the other features the exact same way you saw. I could do the random locations. So you find it's a pretty powerful piece of software. Certainly gives us a lot of different ways to start to pick different features, bring them in, add them to programs, and kind of work from it there. Okay, so at this point, we are at the end of our formal presentation section. It's been relatively decent on time, all considering. So now we want to kind of open up and kind of field any questions you guys have. So certainly, as in the past, the questions do not have to be specific to this topic, but in this case, either way. But why don't we start to take a look and we can field some questions. All right, so let me pull up my Q&A and read through some of this stuff, and we can talk about it. So bear with me 1 second. All right. Okay, hold on 1 sec. All right. What do we got now? Okay. We had some earlier questions we were talking about, so I'm just trying to filter down. Okay. Oh, so this is interesting. So Danny Vitullo, my colleague, he's on our call, and he had mentioned about what happens when windows get lost. And this was actually a nice little exercise I ran into when I was getting ready for this webinar. So what happens, and I guess this is kind of common on a lot of different programs. I had never run into it myself before. I got into a scenario where I was pulling up my options window, and it wasn't here, and I thought the software was actually locking up, because what happens is if you click on the outside of the option window, you can't access anything because the window's up. But the window actually was way off the screen, and I couldn't get to the window to bring it back on. So I found, actually through Google, our best friend Google, that if a scenario like that happens, if you do an Alt and spacebar routine, it will give you a pop-up, and then if you click on the Move option and use your arrows, you can move around the window. So I actually was able to jog the window back into the display area. So if you ever run into that, if you ever run in where you think, maybe you think the actual software is hung up, it's not hung up. The window, and sometimes I got multiple screens and I'm moving software in and out and resizing things all the time. So somehow it just got trapped where this window was off the screen. And the only way for me to get back on was that little trick. So it's a neat little trick to use. You do the Alt and space bar, and that will bring up your little pull bar. Now, when you click Move, don't try to use your mouse, because your mouse actually can't get there because it's off display. The trick after this is to use the arrow buttons to jog the panel back into visible display. And then once you get it there, you can move it around with your mouse and do all your normal stuff. So I tell you, that ran me around a little bit when I ran into that. Okay. All right, so Nasser is asking a question, but I think it's chopping off. So if you do me a favor and retype you're down a little further. I'll get down to them. Okay. Got some other questions here. How do you get the options window back into view? That's what we just talked about. All right. Here's another question. What if the machine gets interrupted while cutting a part by any reason, let's say power cutoff or tool breakage? How do I get up and running from the same block? Oh, this is a good question. That the machine had been interrupted by. So certainly a little off topic to the content, but let's handle this question. So what Nasser's asking about is, let's say I'm running, something happens, E-steps gets hit, something along those lines. How do we resume the program that the system was running? So let's say for argument's sake, this machine, I'm running this program. So let's do a quick reset. This should be valid enough to run. So we're running, and oh my goodness, I hit the reset key or E-stop. Now, this won't help you in a condition where you get a power loss. Power loss will require additional hardware and whatnot. But what happens is any condition other than the power totally dropping out, when you go to your block search option, there's a function called interruption point. So the system recorded the position that you were last in. So had I jogged the machine away, moved to some totally random location, if you hit interruption point and do the normal start search, as you typically would, block search in the middle of a program and say, okay, and cycle start, the machine will start exactly at the point. So it'll vector, it takes the shortest path to get to the point at which it was stopped or interrupted, in this case by a reset, and then continue cutting from that point. So that's the big trick there, short of the power up, the power down scenario. If you lose power, you're going to have to at least start from the start of a block. So, at any point in time, I can certainly block search down, like if I wanted to start just from the start of this drilling cycle, I can highlight a drilling cycle, block search, start search through that point, and continue on. But what this doesn't help me with is if I'm in the middle of a cycle, in the middle of a milling cycle or whatnot. So in this case, it will have to start from at least the beginning of that routine. But the block search command certainly is obviously the way I would just do any normal starts. But in a case where I lost things like a reset or E-stop, that interruption point is a very handy function. Okay. Here's a different question. How to force the spindle to always stop at a specific angle at any time stopping at the end of an auto program or MDA. So there's not any way I'm directly aware of to force it as to where it's going to stop. but you can position your spindles. So, you know, at the end of a program, if for some reason you wanted it clocked to a specific location, you can position a spindle with what's called an SPOS command. So, you know, in this case, if I was to go over to MDI, oh, I'm still running. Let me cancel it. Go over to MDI. You can type a command called SPOS equals, and then you can use any value you want. So, like if I look down here, I have my spindle feedback right now. She's sitting at 288 degrees. So if I was to type SPOS and 30 cycle start, machine will position to that point. Now, this, I need to caveat this. This is assuming you have a Siemens spindle drive and spindle motor. If you're not running Siemens spindle motors, not all builders use our spindle motors and drives, that probably will not work. But if you want to find out, you know, how the builder is applying a spindle orient at least, then you'd want to talk to them. They may be using an M19 command, so you could execute an M19, or they may be doing something completely unique. That is up to the OEM. But as long as it's a spindle, you know, Siemens drive motor combination, this SPOS equals should always work on any machine, because really a spindle motor is no different than an axis motor in our world. Okay. Let's see what else we have. A couple people thanking me for the great job. I appreciate that. Here we go. We got one from my buddy Mike here. I have 20 holes. Is there a way to select all of them at once, or do I have to click on each one? That's a good question, Mike. I think I'd have to play with that myself, because in the randoms, I have to pick them all. I don't recall if I'm selecting any position, you know, like, so like I say, I pick my first one, if I can do some kind of a window. I don't think I can. No, it looks like I got to click them all. I don't know of another trick here. Now, if there are, if they're in relation, you know, like if they're a row of holes, I'm pretty sure then you have the ability of clicking and it'll kind of automatically click through. In this case, I don't have an example of holes in a row. So if you had those holes, those 20 holes, and they were in line or in a grid, then I think it'll auto-select. But if they're random holes, I'm pretty sure you're going to have to pick each one individually. But play around with it. You might find a trick that I don't know of. All right. Good. And let me see here. Hold on one sec. Sorry, guys. Just picking another spot. We talked about this briefly, but just to revisit it, can I import 3D files? You know, a lot of guys certainly trying to do 3D surface work or whatnot. And again, back to what I said earlier in relation to like a DXF file. DXFs only support 2D, so no, this will not support a 3D scenario. But in the same token, if I had a 2D profile that was like in a YZ or an XZ orientation, I certainly could pick that feature and then apply that to one of our milling cutter paths and maybe, you know, loop it over. So you can do some pretty tricky stuff if you want to get out to it and kind of play around with the 3D shape. But if you're truly talking about a true free-form three-dimensional shape, you would need to use a CAD/CAM package to support that kind of geometry. And then somebody here was asking about support for turning. We did mention upon that again, but to refresh that, if you go to settings and you go to your options, you just have to make sure that you pick the shop turn function if you're doing conversational turning, or you use the default like we just looked at if you're doing ProgramGuide turning. All right, and let me just take a quick peek. Looks like we've handled everybody's questions. All right, so with that being said, let us shut off the recorder. All right.